Yesterday we talked about circles and tangents to circles and discussed some theorems. We said that a tangent to a circle is a line that intersects the circle in exactly one point. We called this point the point of tangency. And we introduced a theorem that says that a tangent line is always perpendicular to the radius of the circle at the point of tangency. We will continue working with tangents today. I am passing out these sheets. In the figure, there are two lines A and B, and they intersect at a point P. You will also see that I have marked a point A on line A and a point B on line B. I want you to draw a circle that is tangent to A at A and tangent to B at B.
Okay. I'll go get it. You stay here.
Otherwise, you're gonna have two. It's gonna be tangent in two places.
Yeah, it looks impossible.
Yeah, compass.
This is silly.
Okay, would someone like to come up to the board and draw the circle? Alpha, can you share with us what you thought?
Well, I made something like this.
That's not a circle.
Well, pretend it's a circle. I would need a compass to make it precise. Plus, it doesn't need to be precise on the board. But see, what matters is that it's still tangent to both lines.
Alpha, did you make the drawing with a compass on your sheet?
Actually, I didn't need to use a compass. I just drew a circle and it came out much nicer than now.
What do you all think of Alpha's circle?
I don't know. I've been trying to draw several different circles with a compass, but I can't get it right. One of the lines always turns out not tangent.
I'm telling you, man, it's easier without the compass.
Well, if you move the points just a little bit, you could do it with the compass. Here.
That's clever. Why don't you just change the whole thing then?
I thought it was important to get the points in the right place, or else...
Did anyone succeed at drawing a circle tangent to the two given points?
Is mine good enough?
That's a bold
That doesn't count.
Is that
circle.
tangent?
Ro, here, why don't you sharpen your compass and try drawing a cleaner circle that is tangent to lines A and B at A and B on this new sheet. Those of you who did not yet get a compass, go to the cabinet and get yourself one. Alpha, you too.
It doesn't work. Are you sure it can be done?
I drew a circle tangent to A and another circle tangent to B. One point, not to both of them. Did you mean one circle tangent to both points, or one circle tangent to each point?
It says tangent to A and B. That means to me one circle.
That is what I meant, yes. One circle tangent to both at the same time. Did you do it, Lambda?
No, it's impossible.
You just didn't want to do it.
Why do you say this is impossible? Have you tried to draw it?
Because it doesn't work. Nobody could draw the circle you wanted.
You sound pretty sure of yourself, Lambda. Do you have any idea how you are going to argue your point?
Hey, Lambda, what's wrong with you?
Say, Lambda, what about my picture?
Well, I just think that there's something wrong with this picture. If we could move the points a bit, we could draw a circle, just like I did on my sheet. But Beta here said that was cheating.
Well, if you could just draw the circle first and then pick the points, then draw the lines, that would be much easier too.
But that's not what we're supposed to be doing.
Wouldn't it be nice to be able to make up your own problems?
Okay, Lambda, let's suppose I now have these two lines, L and M intersecting at Q. M is a point on M. Where would you place point L on line L so that you could draw a circle tangent to both?
I think just above M.
And why is that?
I'm not sure. I think that's what I got while drawing different circles on the worksheet.
Lambda suggested that point L should be just above point M. I suppose what she meant was that if we drew a line perpendicular to M through M, the point of intersection of that line with L would be just above M. Here, like that. Is this what you meant, Lambda?
I guess so. I'm not sure.
So, all of you, draw a figure like mine. A horizontal line M and a slanted line L. Put a point M on M, and then to find point L, draw perpendicular to line M through M. According to Lambda, the other point L is the intersection of the perpendicular with line L. Now use the compass to draw one circle that is tangent to M at M and tangent to L at L.
Hey, that works better. Almost.
No, it doesn't work. It should be closer. My L is too far.
Too far?
Can't you just open your compass bigger?
I tried that, but it either doesn't touch the line, or it touches in two places.
Is one of those points L?
Yep, and the other point is below it.
So can't you just make the radius a little bit smaller now and make a tangent at that point?
Ro, show in here how you would draw the circle.
I was thinking that first I get the midpoint of L and M. Say that one is my center. And I draw one circle that passes through M and L, and I get this other point up next to L.
Label your points. Put a C for center and an X for the new point.
So I was thinking now I could just draw a circle with radius X, and it will only touch L in there, not in L anymore.
That's an interesting idea. Has anybody tried what Ro suggests?
That doesn't make any sense to me. The radius is the same whether it's at X or at L, isn't it? It will still cross the line L in 2 points.
Well, I was thinking of making the center somewhere else, in between X and M now.
What makes you think that will solve the problem?
This line MX is now perpendicular to line L, so it's not going to touch the line in another point.
Yeah, but the problem will now be in the line below. You'll kind of have 2 points there now.
Why?
Because the line X to M is perpendicular to line L, but not to line M anymore.
Yeah, maybe it has to be perpendicular to both lines.
Well, it obviously can't be perpendicular to those 2 lines, since those lines aren't parallel.
That's not what I meant. I meant to say make perpendiculars from X and from M, and where they meet, there's the center.
Let's try what Theta just suggested. So all of you, draw the perpendiculars and the new center, then try to draw the circle, but use a compass.
Hey, that should work. Well, wait a minute.
No, it doesn't work. The perpendicular from M is the same we already had. You surely don't want the center of the circle at M, do you?
Gamma just made the point that if you take perpendiculars from X and from M and look for their intersection, they intersect at M. And M cannot be the center of the tangent circle. Can somebody explain why Theta's theory fails?
Well, I don't think it fails completely. It's more like you should pick another point, not M. If you pick a point closer to Q, the perpendiculars will cross inside the angle.
Yeah, maybe the point has to be at the same distance from Q?
What do you mean, Alpha?
That's kind of what I did earlier when I moved the points around.
Yes, Lambda, but Alpha wants to move them differently. Alpha?
Well, if you just take the same distance from Q to X and make it a point on line M, say Y, then you could do Theta's theory and it will work.
So Alpha and Lambda are suggesting that points X and Y, which are equidistant from Q, can be the points where you apply Theta's idea. What do you think, Theta? What would your theory say to do now?
I would say now, draw the lines perpendicular at X and Y, and where they meet, make the center.
Try what Theta and Alpha are proposing and see whether you get a tangent circle.
It works.
Yeah.
Bingo.
Yeah.
Cool.
Could you all draw a circle tangent to M and L this time?
Yeah, totally.
Okay, before I tell you the theorem that we will learn today, I want you all to draw 2 new intersecting lines like M and L and draw a circle tangent to both. Wonderful! What we just did is we discovered a new theorem. The theorem says that if 2 intersecting lines are tangent to a circle, the points of tangency are equidistant from the point of intersection. Okay, who wants to try to prove that?
Do we need to prove this?
Yeah, we already know it's true.
Will the proof be on the test?
Of course we need to prove this theorem. We cannot assume it is true just because it looks true. We can only accept a theorem as true if we have proved it.